Hello and welcome to Scratch Forum Replies. Today we have Touch Creator who asks, how do I make a BIOS? I don't mean an actual BIOS, I mean to simulate a BIOS, the one you see when you spam a key at startup. BIOS stands for Basic Input-Output System. As you can see here in Wikipedia, it's the first software that runs when a computer is powered on. To answer this question, I looked up a few open source BIOS software that exists on the internet. One of them is called Boot. If you go to Boot's project page, you can see how to get the source code for it. It's by running this git clone command, which will copy the source code onto your computer. You can see here that it is a distribution of a different project called Coreboot. After I downloaded the Boot distribution, I saw that Coreboot was probably mostly the code that was running. So I looked that up online and found the documentation for Coreboot. There's a copy of it on GitHub at this URL here. You can see in the diagram of the overall structure of Coreboot that when the program starts running, it has several stages. There's a stage that's called boot block, a stage that's called ROM stage, a stage that's called RAM stage, and then one called payload. And there's a few other stages that happen, some of them on some types of processors and other ones on other types of processors. And this ver stage that's optional. If you look at the code of Coreboot, this appears to be the main function, which is the first thing that runs when the CPU chip in your computer turns on. This would be similar to the when flag click block in Scratch. This is the first thing that runs, just like the flag clicked is the first thing that happens in Scratch. These pieces of code with the parentheses after them are function calls. Those are like your pink blocks in Scratch that call into a custom block. So init timer would be very similar to pink make your own block in Scratch. And there's another function here called boot block main with timestamp. It takes a few parameters and it's actually defined up here. So this is similar to where you define what your custom block does, and it tells which parameters that you can pass into your custom function. I looked through this code for a little while, and I'm not very familiar with it, but it looks like all of these initialization functions will run pretty quickly and then exit. The fact that they're stacked one on top of the other like this is very similar to how in Scratch you can stack one block on top of the other. The last function in this stack is called run ROM stage. That is in the diagram over here. And you can see that's the last thing that's done in here. The way that this code base seems to work is that each function that is defined will, as the last thing it does, call the next one. That would be similar to if in Scratch you created custom functions called boot block and ROM stage and RAM stage and payload, and then at the end of boot block you called ROM stage. That would be here. And at the end of ROM stage you call RAM stage, etc. When you find the run ROM stage function in the code, you can see that it has a similar structure. It runs vboot run logic and some things that depend on what type of CPU you're running, some timestamp add now, which I think are probably logs, and report, and then finally it calls progrun, which looks like it's the main part of what happens. Finally, at the very end it calls halt, which I'm suspecting sends the CPU a command to say stop running any more instructions. So this would be similar to in Scratch when you say stop all scripts, which means that most of the time you would expect that a computer that's booting using this BIOS, this function would never exit, because if it did, then the computer would entirely halt and not do anything else at all. When you find the progrun function, it does two things. It calls platform progrun and arch progrun. When you find arch progrun, at the end of arch progrun, there's this call to this function called doit. Unlike in Scratch, a function in C, which is what this code is written in, could be a variable. Here, there's a doit variable that contains the output of what happens when you call this other prog entry function. but that variable isn't a number or a string of characters or a boolean. Instead, it is a function, and you can call it. And in this way, your program can do much more powerful things. What I think is happening here, and I'm not an expert in BIOSes, and this is the first time that I've looked at this code, what I think is happening here is that this function that is returned by prog entry arg is pointing at the spot in memory that the bootloader is located at. And if you happen to know anything more about this, please leave a message in the comments, because I'm definitely not an expert. This is the first time I'm seeing this code. If you look at what prog entry does, it looks like it's a data structure that contains the location of where that bootloader would be, which will depend if you're running Windows or Linux or something else. It will point out whichever of those things you're using. You can see that prog is something that's passed in as a parameter to this arch_prog_run function, which is coming again as a parameter to prog_run, which again is coming as a parameter when prog_run is called from run ROM stage. And this is the point where my understanding of what's happening here is running out, but something about this function is calculating where to find the bootloader code so that this BIOS can hand off control of the computer to whichever operating system you're running. Hope that was helpful. Please subscribe to the channel and hit the thumbs up button on the video, and leave a comment if you know anything else about BIOSes or have any suggestions of other things to cover. Thank you for listening, and talk to you next time.